Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Good morning. Please take your seats. We're ready to get started. So my name is Dennis Gannon. I am the co-chair, along with Judith Bishop here, of the 12th Annual Microsoft Research Faculty Summit. We really are excited about today's events. Our theme is Future of Computing, and we hope that we've captured through the sessions that we've created our vision of many of the things that are going to be important for the future. And before we get going on this, I wanted to point out a couple of things here. First of all, make sure that you get a copy of the program that's available. For those of you that are like me and hate lugging around the big program, we have this handy-dandy little one-pager that you can pick up, and it's over by the speakers check-in thing. We're not sure why it's there. Even if you're not a speaker, you could have one of these, so that's very handy, pocket size. Plus, I know you all have Windows phones, and those of you with Windows phones, we have a special phone app with the program in it, so you can download that, or you can load it into your Zoom, which I'm sure you also have. So we're pleased to see you. One of the things about this event that's very important is it's a chance for all of our academic colleagues to interact with our Microsoft Research colleagues and to get to know each other and have a lot of fun. Now, at this point, I'm going to turn it over to Judith, who's going to make an introduction.
Thank you, Dennis. Once again, I just want to say how wonderful it is to see so many friends, old, and the ones that we're going to make over the next few days will become new friends. And my job now is, it's a great pleasure to introduce Tony Hay, who is our Corporate Vice President for Microsoft Research Connections and is responsible for worldwide external research collaboration for Microsoft Research. Prior to coming to Microsoft, Tony had a distinguished academic career. He was head of the School of Electronics and Computer Science at the University of Southampton in Great Britain, and he built that up to a department of leading standing in the UK. He then served as director of the UK's eScience initiative, managing the government's efforts to provide scientists and researchers with access to key computing technologies. He is a fellow of the UK's Royal Academy of Engineering and the American Association of the Advancement of Science. He is also a fellow of the British Computer Society, the Institute of Engineering and Technology, and the Institute of Physics. And in 2005, he was awarded Commander of the Order of the British Empire. So please welcome Commander Dr. Tony Hay.
Thank you very much. Thanks very much, Dennis. Yes, well, we don't have much of an empire.
Particularly this week.
Anyway, so it's great to be here, and it's wonderful to see you all here. So it's the 12th Faculty Summit we've had at Microsoft Research, and its purpose is really, it's a research conference, it's dialogue, it's an exchange of views. We've made sure, for example, that there's no session which has only Microsoft speakers. There's a genuine exchange of views. And so that's the purpose of the event. This year's theme is Future World, and what we would like to see is how technologies such as natural user interface, the cloud, machine learning, how is it going to affect the way the world evolves in our daily lives, in our workplace, and how we address significant scientific and social challenges. So there's some statistics up on the slide here, and it's great that we have over 200 first-time attendees, and I hope you have a very interesting day, and you'll give us feedback at the end of the day as to what we did right and what you might like to see next time you come. So we have a very exciting and diverse program. We kick off in a moment with Craig Munday, who I'll introduce later. He's our Chief Strategy and Tech Policy Officer, and we have also Peter Lee, who is now our new Redmond Lab Research Director, and he will be talking about his experiences as a professor in the university, as a in government research, in DARPA, and latterly in industry in Microsoft Research. On Tuesday, we have Rick Rashid presenting our faculty fellows and talking about some of our community programs. And we have a keynote from Rick Stilitsky about vision-based natural user interfaces. And on Wednesday, we have a closing keynote, which is from Lily Cheng, who's going to tell us about future social experiences. So I think those are sort of anchor points to the program. We've tried to do something different this year. We've had fewer parallel sessions, but we've tried to make them exciting and interesting, and we've listed some of them on the slide. It's a different format. Instead of the cruise being tonight, the boat cruise is tomorrow, for example, which I hope you'll enjoy. And we look forward to your feedback on the format of the meeting and whether having an extra half day on the Wednesday, you think this is a good idea or not. So that's what we're going to do in just a moment. But first of all, I'd like to tell you about Microsoft Research Connections. So Research Connections is our new name for our collaborative research with universities. And what we're trying to do is work with the academic research community to speed research, improve education, and foster innovation. And that's our mission statement. And we do that through collaborations with scientists trying to use state-of-the-art computer science research to help scientists solve problems that we care about and humanity cares about, like disease or environment. We also believe it's important that we build the next generation of computer science community, because that's going to be a key community for the world in the future. So we need to inspire computer scientists as well as research scientists. And we hope, and that's what some of our projects are trying to see, if we can accelerate scientific exploration using some of our tools. And I'll give some examples from each of these in just a moment. So these are a list of projects that we've been doing last year, and some we're going to focus on in the coming years. And what I'd like to do is just pick out a few highlights of these, just that you can then go and find out more during the conference. So in computer science, we have try F#. Now, F# is a functional programming language, and I remember in the 80s, functional programming languages were going to be the future. Well, that's still true. But I think actually we may be making a breakthrough with try F#. So it's really got some interesting features and enables you, for example, it's people in the finance community like it because they can specify units, so they can specify currencies, for example, in the language, and you can't make mistakes because it's very type safe and so on. We also have been working quite hard to find out how you actually can give academics access to huge data sets, realistic sized data sets in which they can try new algorithms, new experiments, and so on. And so Evelyn Villegas has been working with the Bing team, trying to give Bing data so you can actually do experiments. And there's the WebNgram services, which is currently out there. And later on this week, there'll be a session on the Speller Challenge, which is actually a competition to develop new algorithms based on this data. And we also will see in this meeting, Project Hawaii, which is actually generically trying to help educators teach, if you have a smartphone and cloud services, what sort of cool applications can you put together. And so there'll be lots of examples, and there's something in the demo fest that you can find out. So those are just 3 examples, and the picture at the bottom is from our spring meeting in Paris on software, which was really very exciting, and the Eiffel Tower did its job. Right. This is some of our science engagements, Earth, Energy, Environment. I'm sure most of you know about Worldwide Telescope, which is a great visualization and exploration tool for astronomers. What we're now trying to do is instead of looking outwards, to look inwards onto the Earth, and to allow scientists to import their data using a simple add-in for Excel. And so they can use geospatial data with temporal information. And so here you see a visualization of earthquakes. That's part of the Ring of Fire if it goes on, that's where we are in Seattle. We're also on that ring, and you can see ways of rendering different types of data. So we're hoping to look at exciting things to help scientists do visualizations, location, depth, magnitude, time, all this sort of information that they should be able to read off very simply. We're also, with our machine learning scientists, applying those in a number of areas, principally around genetics. And so we've talked in the past about our work on HIV/AIDS. We believe we have some understanding of how you might make a vaccine that's effective for HIV/AIDS. And so one of the projects we're actually doing is doing a trial vaccine. And that's at a very exciting stage, and maybe one of these days we can tell you if it works. Other things we're doing, looking at other diseases which are going to be very important, like asthma and diabetes. And again, using machine learning techniques, they've made significant discoveries in that space. And in Brazil, they run their cars on ethanol, and they have a lot of sugarcane there. And the question we've been looking with researchers in Brazil is can we do sequence the whole of the gene of sugarcane, which hasn't been done. It's a very large sequence. Can we assemble it and enable them to engineer more efficient ways of producing ethanol from sugarcane? So that's at the beginning, and what we're trying to do here is put together a set of tools that will enable you to do that. So this is one of the examples of the toolkit. This is a toolkit for bioinformatics and how you can actually assemble and compare DNA sequences for these very large sequences. So we're trying to do that, and that will be available under open source, and we're hoping to give it to an open source foundation, about which I'll talk a little bit in a moment. So those are applications to science, but just to show that it isn't all science, we believe that social sciences and the humanities and the arts are also going to have needs of visualization tools and manipulating and managing digital data in conjunction with the sort of artifacts that they deal with. So the humanities and the arts and social sciences are an important place, and I just thought I'd show one. This is a great example of a project we did at Berkeley with Walter Alvarez. It's a multidisciplinary. Walter Alvarez is a professor of geology. He's the son of a Nobel Prize winner particle physicist, and he and his father pieced together from paleontology, from geophysics, from chemistry, an understanding of the death of the dinosaurs by a meteorite. So these were the guys who did it, and the iridium deposits were the key signature of that event. And so it's multidisciplinary, where you want to put lots of different types of data. So this big history agenda is actually trying to compare not only chemistry data, but paleontological data, geographic data, all this stuff on very large timescales, from seconds up to billions of years. And how can you actually browse that and compare and do these things in an easy way? And that's what this project Chronos Zoom does, and we're taking that forward in the next stage. But let me just show you one quick demo here of that. This is from their web page. This is the whole of cosmic history. So down at the bottom here, that's the Big Bang, first 3 minutes. And up here is the whole of evolution of life. Pre-human history is about here, where like a thickness of a sheet of paper is human history here. And then this is the evolution of the planets. This is the whole accelerating expansion of the universe. So you can put huge events on this, and you can go and zoom in on various things. So you can zoom in on the Big Bang and look in detail about the various features of the Big Bang, go back to cosmic history, go back to the formation of the planets. And so you can see here, this is a large amount of the climate, the impact history, production of continental crust, Earth's interior, and then this is the family tree of humanity from the DNA emerging. And so you can go to human prehistory, which is just this little bit up here. That's the emergence of humans. And then you can go to our history, which is this little tiny piece up here. Okay. So how you can put all this stuff together is tools like that, I think, are going to be interesting. You see it disappearing into the background. So these sort of tools, I think, will be exciting, and more than just amusing, I think they will actually be real research tools in the future, and that's one of the things we're looking at with big time. We also, just to emphasize, we collaborate in all the regions. So in Asia, they have a great e-heritage project with a gigapixel camera doing all sorts of wonderful things with museums and art galleries. In Brazil, they have lots of forests, as I'm sure you all know, and so we have a rainforest sensors project. And in India, there's a great tool called Rich Interactive Narratives. You can go and see some demos on digitalnarratives.net on the web, which puts together a whole variety of vision technologies, from the deep zoom you just saw, through photosynth, where you can explore inside a Buddhist temple, for example, and sort of worldwide telescope type tours. So a whole range of technologies, and we hope to make that into a tool that you can use either professionally or with a class of school kids, and we believe it has great interest. And in Europe, just take one project we're doing with the European Commission. We're doing a project called Venus C, which is about exploring the use of cloud computing. And one of the examples is this virtual fire project, which took place in Greece after the terrible fires they had on the mainland in Greece some years ago. This is an early warning system which uses cloud data, cloud computation, risk management modeling, and so on, puts it all together, and so you can actually have an early warning. You can see where there might be high risk for fires, and you can do things about it. So this is just one example. Venus C has a whole range of examples there. So what I'd like to talk about is another of the areas that particularly fascinates me, which is the transformation of scholarly communication. In many ways, data is one, but just to look at this statistic from ISI here, approximately 3,000 scientific articles are published per day, roughly one every 10 seconds of a working day. We can now expect that these papers will, each year, cite around 5 million previous publications, and the rate of production of scientific papers is quadrupling every generation. So even if you're just looking at a specific subset like biomedical, in PubMed Central, 2 papers a minute are deposited every day in PubMed abstracts. And how do we keep tabs on that? How do we alert themselves? How do we find out what research has been done? How do we make research more efficient? How do we avoid duplicating and really wasting resources when the Earth badly needs a solution to disease, to cancer, to HIV, and so on? Really, we'd like to make that process more efficient. So it clearly shows that the percentage of human knowledge that one scientist can absorb is rapidly heading to zero. Right. So I'd like to draw your attention to one of the sessions on Wednesday, which is about academic search. And so academic search is a powerful search tool for academic papers. It comes from our MSR Asia lab in Beijing, where they've been working on this project for some time. Historically, we've focused on computer science, but we've now been increasing that to include other disciplines, such as the physics and stuff that's in the archive repository, or the biomedical literature that's in PubMed Central, for example. And what you can do is you can play in many ways. You can find the top papers, you can find the top cited authors, conferences, journals, and so on. And you can then drill down and find specific papers. You can find out where you can get the journal version, where there is a version on the website of the author, and so on. And there's a nice little tool about relationships between authors. It's a visual explorer tool, and what we've shown here is I tried to think of the most connected computer scientist to show, and I thought Andy Van Dam. So that's a picture of Andy's collaborative things, and you can drill down on any of these and see who they connect with. So it gives you a whole connectivity of the way the research has spread out from individual researchers and whole networks. So with a tool like this, you can then produce, for example, league tables, and you can choose what parameters you like. And so I carefully looked very hard to find a ranking that would give Microsoft Research top, and this is one. So this is actually, if I take the last 5 years, that's important, and look at citations, Microsoft Research beats Stanford, MIT, but you can look at these sort of things, and these are important rankings because people will look at these sort of events and impact factors, citations, total number of publications. These are things that governments want to use. They want to use it as a basis for funding, for example, and what we would like to do is make it so you can decide what you want to rank them on. This is just one I found that shows us in good light, but you may want to find another version which does things differently. And so on the session on Wednesday, you'll find an interesting talk by Jevan West from the eigenfactor.org down in UW here in the biology department, where using an API that we make available for the academic search, you can build your own tools and you can actually decide what you want. So here, this is an example here, recommend, map, explore, and rank. And so what Jevan's been looking at is citation networks and better ways to actually rank papers and significance and so on. So what we've been trying to do here is give you the opportunity to build your own recommendation system, your own ranking system, because these things are important and they can be important for funding. In the UK, one of the reasons I left academia was I did 3 years of ranking of departments. And as Dean of Engineering, my last act was to get every single department in my faculty in the top rank. And obviously the only place to go from there was down, so it was definitely time to leave. But it's a very arduous process, and I think really very imperfect tools, just citations, just impact factors, are not the whole story, and we'd like to give you the opportunity to build what you think is relevant, and that's what the session on Wednesday will be about. So I do recommend those of you who are interested in those sort of things, that's an interesting and exciting development, we believe. We'd like to make it so you can help us build something that's useful for you. I like this quote, all right? The first thing most of us think about when we hear the word open is Windows. Now, do you know who said that? Well, the answer is very interesting. Steve Jobs, in October 2010. What he meant was that Windows is an open platform that you can build lots of applications on. And obviously it's in contrast to other companies, shall we say. Okay, so that's meant as a lead-in to the fact that Microsoft is sponsoring an open source foundation called the Outer Curve Foundation. I'm a board member. Microsoft has 2 board members out of 5. And the idea is to have an open source foundation which is not specific to a specific technology like Eclipse for Java. This is actually technology agnostic. It's also, you can choose whatever open source license you like. It's license agnostic, and it's forge agnostic. You can put your software in any forge you like. And it's a more generic thing. Yes, it has projects built around Microsoft products, and the community are developing and taking code. What we've developed, they use this metaphor of a museum and a gallery. So there are various galleries. The gallery that my team sponsor is the Research Accelerators Gallery. And what we're trying to do is to actually make it available for scientists to lead projects. So Project Trident, for example, is a workflow project, and we're working with Beth Playley in Indiana to try and see if we can make that into a tool that people can use. They can choose to use this, that can interoperate with various other tools that they want to use. So we're exploring, and we would like to work with the community to take that further forward. Similarly, with our chemistry add-in for Word, it sounds a very trivial thing that you can type equations in Word like CH4, for methane, but because it's used something like chemical markup language, that means the computer has enough information to give you either methane, CH4, or the chemical structure. So it's a very exciting beginning of semantic chemistry, and that's led by Peter Murray Rust at Cambridge University, and we are, with the foundation who own the IP of that, it means that Microsoft people in my team can collaborate with them on that in the way that doesn't jeopardize any of Microsoft's rights, and it enables them to collaborate in open source projects. And the longest standing project is Conference XP with Richard Anderson at UW. That's a collaborative communication tool which has been around a long time, and now it's available under an Apache license. These are all standard open source licenses, and what we hope to do is put Biological Foundation in there and other tools as we come on. And if there are things that we should be doing that you'd like us to do, then we would be very happy to take ideas and to work with you to develop galleries that actually you want to do. So that's just a brief run through of some of the things, of the projects we do, some of the tools, and what we're trying to do to make Microsoft an open platform where people can add things, can extend things, use things that are useful for their research, both in computer science and also for scientists doing their research. So the last thing I have to say is thank you to Dennis, to Judith, and to Harold, and to many others who've worked very hard over the past 6 months to make this event possible. You've all got programs that Dennis and Judith prepared and showed you, so you choose the sessions you want, but don't feel you have to go to all the sessions. You can use the space for networking. That's part of the purpose. You can actually meet the researchers in Microsoft Research doing the research that you're interested in, and this is an opportunity to begin to collaborate and to see how we can develop projects together. So use the opportunity to find researchers doing things that you want to do and to talk to them. This is a great networking opportunity. So make sure you have a good time, and I hope the weather stays fine. At the moment it's behaving itself today, and so thank you very much for coming. Thank you for listening. Thank you.